So day 5, secant and tangent lines, we're going to be talking about each of those and relating them to what we talked about in yesterday in day 4 with average rates of change and instantaneous rates of change. So starting off with a secant line is just a curve that passes through any 2 points on the curve. So we have our 2 points here and here. So it's a secant line. And then we also have tangent lines, and tangent lines just graze the graph at a particular point. So in this case, you can see the one here that I'm highlighting, it grazes that quadratic right at that one particular point. So if we were to relate this to what we were doing yesterday, average rate of change is just the slope of the line connecting the 2 points. The average rate of change is just your secant line. And then the tangent line, the only difference between average rate of change and instantaneous was you plugged in 0. You made the distance between those 2 points go to 0. That's why we had the limit as h approaches 0 to get that tangent line. So tangent lines are just the instantaneous rate of change. So using that concept, we're going to be just kind of going through this with this particular quadratic, negative x squared plus 4x plus 3. And we're going to be finding the secant line through 1 and 3. So here's 1 and here's 3 on the graph. We want to find the slope of the secant line through those 2 points. So this line right here. It looks pretty close to 0, but we're going to verify it algebraically. So let's go ahead and do that. So we're going to find the average rate of change, and that is equal to f of 3 minus f of 1 all over 3 minus 1. So we're going to have to take that 3 and we're going to have to plug it in everywhere we see an x right there. So we have to do 3 squared, then make it negative, then do 4 times 3 plus 3. And when we do that, we end up getting 6. And then I'm going to do the same thing by plugging in 1 to each of those, and I get 6 as well. And then that's all over 2. So it does look like that slope of that secant line is 0. So we will say the average rate of change is equal to 0. All right, now next one is we're going to narrow down that interval. Now we're going to go between 1 and 2. So if I go between 1 and 2, we're actually finding the slope of the line through these 2 points. I'm trying to do my best here. And so from this point, we're going to do the same thing. This time we're going to do f of 2 minus f of 1 all over 2 minus 1. So when I plug in 2, I end up getting 7. And when I plug in 1, it's still 6 all over 1. So it looks like that slope right here, the slope of that line, is equal to 1. And then we're going to narrow it down even further. And then this time we're going to go between 1 and 1.5. Our goal is to just keep narrowing this, trying to get as close to 1 as possible by narrowing our interval down or making our h smaller, if you will. So we'll just do f of 1.5 minus f of 1 all over 1.5 minus 1. I think when you plug in 1.5, you get 6.75. And then it's still 6, and then this time it's going to be a half. So this time we get 3/4 over 1/2. I do a lot better with fractions. So I'm going to multiply by 2 over 1, and that looks like it's going to be 3/2. So the slope of this line in red is actually 3/2. And so what they're asking you to do in part D is they want you to notice what's happening as you get closer and closer to 1. It says, as these points get closer to 1, what happens to the slope of the secant line? So if you'll notice, we're just narrowing down the interval. Eventually, we're going to get to that slope of just that line tangent. We're going to get that exact slope, or the instantaneous rate of change. So all we're going to say here is it approaches the slope of the tangent line. Okay, so that's what our goal is. When we narrow down an interval and keep making that change smaller and smaller, we're actually getting to the tangent line at a particular point. All right, so what we're going to do is we're going to jump to number 7. I wanted to just go through one problem with you that's kind of the main concept of you actually finding the equation of the tangent line. So here's what it says. Mathematics is full of all kinds of amazing equations, but it's comforting to know that some things remain constant for all of them. So for example, the slope of the tangent line, that's what we're going to be doing, of a function at x equals 2, you can follow the same procedure regardless of the function. You actually have 4 functions you're going to be finding the slope of the tangent line to. So here's what you'll be doing. It says for each of the following, first find the formula for the slope of the secant line between 2 and 2 plus h. The next thing you're going to be doing is have h approach 0 to find the slope of the tangent line. So we're going to narrow down the interval to eventually where that line will graze the graph at 1 point. And then you're going to estimate that slope to 3 decimals. So let's go ahead and do that. So when you're trying to find the slope of the tangent line at x equals 2, notice how they use the interval 2 to 2 plus h. So we're going to use 2 to 2 plus h to get the slope of the tangent line on that graph. So let's do a little visual. So here's 3 to the x. It's an exponential. Base 3 looks something like this. And what your goal is you're going to find, here's 1, here's 2. You're going to find the slope of the tangent line right here that grazes that 3 to the x graph at one particular point. You want to find the slope of that line. So we're going to use the interval 2 to 2 plus h. So if I have 2 and then here's, let's say, 2 plus h, you're going to find the slope of the secant line and then make that h 0 so that it actually is just at the point 2. So let's go ahead and find that. We're going to take the limit as h approaches 0 because we need to find the instantaneous rate of change where that exact change at 2. So we're going to do 3 to the 2 plus h minus 3 to the 2 all over 2 plus h minus 2. So it's the difference in the y's over the difference in the x's. So I get 3 to the 2 plus h minus 9 all over the 2's cancel, and I get h. So when you find limits from last chapter, you're going to go ahead and plug in h equals 0 here and here. And if you'll notice right away, we end up getting 0 over 0. And when this happened last chapter, we had to make sure that we had to do one of two things. We had to simplify it algebraically by rationalizing or factoring or doing something else. If we could not do that, we had to go to the calculator. And for exponentials last chapter, we did not have a way of simplifying, so that's what we're going to have to do. In order to find the limit, we have to go to the calc. So we're going to go ahead and type in this piece right here and evaluate the limit and try to get as close to 0 as possible. So you're going to open up your Inspire, and then you're going to open a new calculator, or no, you're going to do graphs. And what you'll do is you're going to type in that value. So we're going to have 3 to the 2 plus h. Instead of h's, our calculator is working in terms of x's, so we're going to have to make our h's x's. So it's 3 to the 2 plus x minus 3 to the 2, so minus 3 squared, all over h, and our h's are x's. So here's our graph. And our goal is to find the limit as h approaches 0. So I am going to go to the table. We're going to do a split screen table, and we want to get as close to 0 as we possibly can. So that means that we have to go back to the table. We're going to edit the table settings. We're going to start it at 0, and we're going to change it as close to 0. Remember, I told you to put 5 zeros in. Change it as close to 0 as possible. And it looks like the slope of the line, if you get super close to 0, the slope is 9.888. if you round it to 3 decimal places. So we're going to go ahead and put that right back in our document right here. So this slope is 9.888. That is the instantaneous rate of change, so 9.888. And so what our goal is we've now let h approaches 0. We found that slope of the tangent line. So to do the next part of the problem, B relates to B from the previous part, we want to find the equation of the line tangent. So we already know the slope. It was 9.888 for part B. That's the one we're doing now. Now we have to find that point. So what is the point on this graph of f of x equals 3 to the x when x is 2? So if I plug in 2 into this equation right here, I get 9. So it goes through the point 2, 9. So I have the slope, I have the point. Now I can use this point slope form to actually find the equation of the line. So I'm just going to use that. So they wanted us to also sketch a graph, so we can just kind of take what we've already done here. I'm going to copy it. I will paste it right down here. So I've got this whole thing. It took a little bit extra, but that's okay. I can get rid of that there. All right, so now when I write it in point slope form, I'm going to do y minus, and then it's your y coordinate. So remember, this is x1, y1. So it's y minus the point on the graph is equal to your slope, which is that 9.888. That's what we found. We had to use the calculator, times x minus 2. And that would be the equation of the line tangent to that graph at x equals 2. You can always go back and check it if you want to make sure. Like if I want to type this into the graphing calculator, I would probably want to bring the y over to the other side. You don't have to actually do that. Just you can say this is your answer, but if you want to check, I would probably do 9.88x minus 2 plus 9 to actually see if it actually looked like it was a tangent line. So just to go back really quickly, I'm going to go back and I'm going to go to add a new graphs, and I'm going to do 3 to the x, and there's my graph there, and then I'm going to add on what I think the tangent line equation was, and it was 9.888 times x minus 2, and then I had to add the 9 over to the other side to get it solved for y, and if you check it out, if I kind of scroll down, you can see, I'll do a little screenshot so I can write on it. So you can see at 3 right here, or at 2, it was at x equals 2. You can see, this is a really light pencil. Maybe I should be using a different one here. You can see at x equals 2, you can see that that line grazes it at that one particular point, and you know that you've probably got the right answer just because it's not obviously being a secant point going through 2. So that's an easy way to check to see if you've got your equation correct. So you're going to be doing this for the remainder of the problems. You're going to be following this same procedure where you are going to use the interval 2 to 2 plus h because you're always looking to find the slope of the tangent line at 2. This time your graph is going to be a quadratic, so you want to find the slope of the tangent line at 2. This is going to be a log graph. If you remember log graphs, they went through 1 to 0. They were the inverse of the exponential. And you're going to find the slope of the tangent line at 2. So you're going to be doing this for all these. You're going to find out what the slopes are, and then you will then put it in point slope form to find your equation of your tangent line. All right, so you guys will be having a skill quiz on this. This is an important concept. Please use the solutions in Google Classroom to guide you and see how you're doing. And you'll finish up this worksheet and then ask me questions if you have any on the webinar. All right, guys, have a great day, and I will see you in the next webinar.